Welcome to Spark Learning session. Today we'll be doing code along for clustering. For this exercise, what we have is a case study about seeds from UCI repository. We have seeds or kernels for wheat. There are three kinds of wheat. We have Kama, Rosa, and Canadian. And for these different kind of wheats, we have recorded some information about these kernels of these wheats using a technique called soft X-ray technique. It is done using X-ray Kodak plates. For our information, we have 7 different elements or dimensions that we have recorded using Kodak X-ray plates, such as area, perimeter, compactness, length of kernel, width of kernel, asymmetry coefficient, length of kernel groove. All these values are real valued parameters. Now, our job is to look at the data provided and group them into three groups, that is Kama, Rosa, and Canadian. So let's get started. First of all, as any programming, we need to do initialization or import the required libraries. And we will do just that. We'll import the library that's required. Next, what we need to do is we need to build a Spark session here. That is Spark session with a builder name as cluster. Okay, to create. It creates if it's not there, or it gets if it's there. Now we have to import a data set that we need called data, and Spark would read that. Let Spark read the data set from the CSV file which I have already downloaded before our exercise, and I'll just put it there. I will read the data. Next, we need to it's giving some error. My function seems to be misspelled here. Now let's try it again. It seems to be working now. Now next step is to look at the schema of this data set we just generated. Usually when we do the schema thing, we do three things. We need to look at the schema, describe the data, and look at the head of data. There are three main steps when understanding data. So we have a data. Now we look at the we print the schema of the data. It's a high-level overview of data. Data structures, area, parameter, compactness, length. This is the structure of data. Now we need to get some high-level information about data, such as um, such as this. We look at the describe the data in terms of like a statistics, the count, mean, standard deviation, mean, max, etc. And for area, we have this kind of information. Standard deviation seems to be really not that high, and mean is there. Mean is mean max. Okay, it seems to be good. Now, next step is to get a first line of data. Try to see, look at the data itself. This is more detailed. This is the last step in doing data analysis. Now we're looking at data itself. This is what data looks like. Next step is to format the data. We also want to format the data such that it is in good shape for our data analysis. And the other columns we have, we already know that. Now we need to build some vectors or assembler that assembles this data into a kind of array. And this is what it does. Array vector assembler, data columns, and output the features. We want a feature array, and for that, that's what we're doing here. And we want to append the array in the same data we have. Therefore, we will do append data, assembler, transfer data, as appended data. Now, let's look at the output of this function, print schema. We'll look at that and see we have a features vector or array that has been appended to the data set. And we'll describe that again as usual. I already told you that, right? These are the three steps in doing partial data analysis, and these are we will do one by each one of those. Next step is to do again look at the statistics of appended data, and it doesn't show because it's an array. And next step is to look at the look at the appended data, the one head of the data, or just give sample row and see how it's doing. And we have the features vector right here. This is a dense vector. Now, next step is to scale the data. We need to scale the data. We need to scale the data as usual to make sure that data is in good format, or it is following the regular. It is doing what it should. I'm just moving out of sections because we want to have the proper section in proper place. There you go. Now, next step is to scale the data, and this is what we're going to do exactly that. We format data, now scale the data so that it is in a scale format or normalized format. For that, we need to create a scalar, or that's called standard scalar, and we have that. Now, next step is to create a scalar model or a scale model of data that looks at the data and it models our it models our modeler that fits the data or fits the our scaling that fits the data, your scale model. Then we use a scale model to do the create a scale data here. Now your scale data, scalar model, you transform the appended data into a scale model. And finally, we'll look at the data again in terms of schema. These are scale features we have. We have a scale features, and we want to look at the data. It has appended one new vector called scale features. Look, and then we want to see. It doesn't show anything much because it's there, because it's just a regular data, and we want to check out the head. And this is scale feature of data. 15 has been reduced to 5.5, it's 1400, so it is in scale. Wow, that's really good. Now we need to train evaluate the model. Next step is to train evaluate the model. For that, we need to add one section here. K means scale feature, scale data, and we'll create a model and we'll fit the model to our data, scale data, and it's a fitted model. And next step is to look at the centers in a fitted model. Now, a fitted model, we want to see where the centers are. These are the centers we have for our fitted model. There are three centers, and we'll use this fitted model to get the predictions out of the data we have. it'll give the predictions. This is where all predictions are stored. We want to check out what are those. So we'll add one more line that will show. Show me the predictions. Now these are the predictions it has. It has all taken all the data or 20 rows and categorized them into predictions 0, 1, 2, 3. Now next is evaluate our model. That is evaluate. We have a function called evaluator. We'll use that to create evaluator and then evaluate our predictions. How well we are doing. We want to see that, right? And it is 0.63. It is really near to 1. So this is what we have here. This is now what we did was we created data. We look at the data into from the our University of Irvine, and we use the k-means method to categorize the data into three different sectors or three different groups. And when we did the evaluation of our modeling or our performance of our model, it turned out to be really good. That's all for today. I'll see you next lesson. Thank you so much.